One of the oldest laws in physics is Archimedes' principle. The principle says that if a body is immersed partly or fully, so the statement has two parts. If a body is partly or fully immersed in a fluid at rest, remember this word is very important. The fluid must be at rest with respect to the container. Then the body experiences an upthrust. So the body in both the situation experiences what? An upthrust. This upthrust is known as buoyant force. And the value of the buoyant force is equal to the weight of the volume of the fluid displaced by the body. So in the first case, let us assume that the volume V naught of the body is inside the liquid. And the liquid is, the density of the liquid is rho. So what is the total volume of the fluid that is displaced by the body? The volume that is immersed. So V naught volume of the body that is inside the liquid, obviously that much volume of fluid will be displaced by this body. So V naught is the volume of the fluid displaced. What is the mass of the fluid displaced? Volume multiplied with the density of the fluid. And what is the weight of this fluid that is displaced by the body? Multiplied with G. This is the value of the buoyant force. In the second situation, in this situation, the entire volume of the body is inside the liquid. So how much volume of the fluid the body will displace? Obviously, total volume V. What is the density of the fluid? Volume into density, just like the previous case. So this is the mass of the fluid that is displaced by the body. What is the weight of this fluid? Multiplied with G. So this is going to give you the buoyant force. So fundamentally, the Archimedes principle is saying that when a body is partly or fully immersed in a fluid at rest, the body experiences an upthrust which is equal to the weight of the fluid displaced by the body. And remember in this formula, in both the formulas, whether it is partly or fully, because there is G present, so G plays a major role in Archimedes' principle. So this means that suppose if in such certain situations the value of G becomes 0, can you imagine certain situations where G can be 0? I'll give you some example. Like in case of free fall, G becomes 0 because the net G is 0. It is balanced, right? And at the center of Earth, at the neutral point of two heavenly objects. So in those situations, G becomes 0. This means at the center of Earth, at the satellite which is orbiting around Earth, because the net force is again balanced, or the neutral points. So in any place where G becomes 0, Archimedes' principle fails. So Archimedes' principle, you cannot apply at the center of Earth, a geostationary satellite, or any satellite which is orbiting around Earth. For example, suppose the question is saying that there is a container and here is a fluid and there is a body, and the body is floating in the liquid by 1/4 of its volume inside the liquid. 1/4 of its volume is inside the liquid. And in this situation, the body is in equilibrium. Now, this body is completely taken inside the liquid and released to a depth h. So the body is taken to a depth small h and is released from rest. So initial velocity is 0. So it is released from rest. What is the time taken by this body to come to the liquid surface? Now, first of all, you have to understand that why this body is going to come up. Because the first condition, as it is floating by 1/4 of its volume inside the liquid, that means this body is lighter. This body is not heavier than the liquid. So that's why it is floating. Like in the situation of milk, the cream floats on the surface of the milk. That means which one is heavier? The milk is heavier. That's why the cream is floating on the milk, even though cream is solid. So same thing is happening here. So let us assume that the density of the body is sigma and the density of the liquid is rho. Now, this body is floating. That means the upthrust provided by the liquid, which is known as buoyant force, and the weight of the body must be what? balance. So if this equation is valid, then the body will float. So what is the buoyant force? The buoyant force will be 1/4 of its volume. So let us assume the total volume of this body is V. So how much volume is inside the liquid? It is 1/4. So 1/4 into V of the total volume is inside the liquid. Let us assume the density of the liquid is rho. So what is the mass of the liquid that is being displaced? It is 1/4 into V into rho. By Archimedes principle, this must be multiplied with G will give you the buoyant force. Now we have taken the density of the body as sigma. So what is the mass of the body? It is V sigma. What is its weight? V sigma G. As it is floating, so 1/4 V rho G and V sigma G must be equal. So we cancel Vg and we get sigma by rho is equal to 1/4. Okay. Keep this as equation 1. Now, when we completely immerse the body will experience a buoyant force as well as weight because of gravity. And what will be the buoyant force in this situation? It's going to be V rho G. And what will be the weight? It is going to be V sigma G, right? V is the entire volume of the body of that sphere. Now, because it is completely immersed and we can easily see sigma by rho is a fraction, is a 1/4, it is less than 1. This implies that rho is greater than sigma. So out of buoyant force and weight, which one is more? The buoyant force. This means there is will be an unbalanced force. What is unbalanced force? V rho G minus V sigma G. And the moment we apply unbalanced force, it is Newton's second law. So this is the unbalanced force divided by the mass of the body. What is the mass of the body? V sigma. This is going to give you the acceleration. So you cancel V, you get rho by sigma minus 1 into G. And what is rho by sigma? Sigma by rho is 1/4. So rho by sigma is 4. 4 minus 1 is 3. So acceleration is 3G. So this body will have a 3 times the value of G, that is 30 meter per second square, acceleration in the upward direction, right? And because it is released from rest, so U is 0 and the acceleration is constant, so we are going to apply kinematics. So we'll use the formula A is equal to ut plus half a t square. And what is the displacement of this body? It is h. It is 0. So what is the A? It is 3G. And what is the time? Let me call it T. So T square. The T is coming as 2H by 3G under root. So this body will come up the liquid surface in this time. So this is a very simple discussion of Archimedes principle. I hope you liked the discussion. If you have any doubt regarding Archimedes principle, you can share with me and I'll try to answer them. Thank you for watching. See you in the next video. Tata.